Sure. Okay. What do you guys want to start with? 46. Okay. So, the first thing I'm going to do is I'm going to treat this kind of like a quadratic. These I see both sine squareds and sines in the same problem. And I move everything onto the same side of the equation. Everybody good with this? Now I'm going to imagine, instead of this having signs in it, if it just has like y's, just to make it a little bit easier to see how to do the factoring. You don't really need to do this, but I'm going to do it just to help see our way to the factoring part. So how would I factor y squared minus 6y plus 5? I need two things that multiply to give me positive 5, but add to give me negative 6. Negative 5 and negative 1. Everybody good with that? So I have y minus 1 and y minus 5. I can then set each of these pieces equal to 0 and solve. But I don't want to solve for y, I'm trying to solve for x. So I'm going to replace those y's back with sine x's. Yeah, definitely do. Thank you. So I have x is equal to sine inverse of 0, and x is equal to sine inverse of 5. I still mean 1. I don't know why I got zeros in the brain. Good, thank you. Everybody happy to hear? So to find the solution for when sine x is equal to 1, I'm just going to go and find the places where the y-coordinate is 1 on the unit circle. That happens exactly one place. It's at pi over 2. Then for the other one, I'm going to look for the places where the y-coordinate is 5 on the unit circle. There's none of those. So this part has no solution. So I don't care about it anymore. It's done. So here's my answer for it. Just pi over 2. For part B, we want the answers over the entire real line. So all I need to do is tack on a plus 2 pi k at the end of that. That's my answer for B. My answer for C, remember that for C we're looking for things between negative 2 pi and positive 2 pi. Well, I know that my answers for part A will be there because that's from 0 to 2 pi. But I also need answers now from negative 2 pi to 0, right? So how would I find those? Well, I'm just going to find an angle that's coterminal to this one that lies in that range. I can do that by subtracting 2 pi. And there's all my answers for C. For D, we're looking for things between negative pi and positive 4 pi. Well, I know my answers for part A are going to work because 0 to 2 pi is inside that interval. I, though, still need to worry about from negative pi to 0. Well, I know my negative answers for part C are possibly in that interval, but they could be too small still. So I'll go look at my negative answers from part C. I notice that negative 3 pi over 2 is less than negative 1 pi. So there's nothing in that spot. And then I have to worry about my answers that are from 2 pi to 4 pi. How am I going to find those? I'm going to look for something coterminal to pi over 2. And since they have to be bigger, I should be adding. So when I add 2 pi to this, I get 5 pi over 2. And so that's my answer for D. Megan, were you okay on that one?
Yeah.
Once you've got it into the factored form, it wasn't too bad from there. There wasn't very many solutions, which actually was kind of nice to sort through. There wasn't too much to do. Gotcha. You get it factored? Mm-hmm. Yeah. So when I see like sines and sine squareds and stuff, or like mixes of trig functions sometimes even, we'll see a little bit today in the lesson, I got to start thinking like polynomials. Okay. Who else had one they wanted to look at? Bridget? 34. So the first thing I'm going to do is get the cosine squared by itself. So I'm going to subtract 2 from both sides and then divide by 4. Good with that? We'll square root both sides. So that's going to give me the plus or minus. And then the square root of 3 I can't do anything with, but the square root of 4 is just 2. So to solve for x, I'm going to need to break this into 2 equations. I'll take the cosine inverse of positive 3 pi over, or square root 3 over 2. And then the cosine inverse of negative square root 3 over 2. And then I'll go to my unit circle and look for the x-coordinates where I have square root 3 over 2. So for positive square root 3 over 2, that happens at pi over 6 and 11 pi over 6. For negative square root 3 over 2, that happens at 5 pi over 6 and 7 pi over 6. So that's my answer for A. For B, I'm just going to make an observation here. I notice that these 2 guys are pi units apart. And these 2 guys that are pi units apart. You guys see that? So that's going to allow me to condense from 4 answers with plus 2 pi k, really into just 2 answers that are plus pi k. So for the green ones, I can combine those 2 answers into 1. And similarly for the blue one, I can combine those 2 answers into 1. If you listed all 4, it's not really wrong, but you could do better. So that's my answer for B. For C, we want things between negative pi over 2 and positive pi over 2. So we're going to get all our answers for part A, because that's 0 to 2 pi is certainly inside of that. And then we need our answers from negative 2 pi to 0. So to get those negative answers, what I'm going to need to do is find an angle that's coterminal to each of these and is negative. Well, I'll do that just by subtracting 2 pi from each of those. So I get 11 pi over 6, and then negative pi over 6, and then negative 7 pi over 6, and negative 5 pi over 6. Is everybody okay with me just writing an A there for the answers for part A instead of recopying it again? If there was less of them, I would have recopied them, but 4 is kind of at my breaking point. It's 12:41 on a Friday, on a real kind of miserable looking day outside, so I'm going to just kind of mail that one in there. But we're good with the abbreviation, right? And then for D, we want our answers from negative pi to 4 pi. So we definitely have our answers from part A. That's the stuff from 0 to 2 pi. We're going to get some of our answers from part B for the negative portion. So which one of these are greater than negative pi? Well, there's this one and this one. The other two are too small. So I guess I'll recopy those answers. I don't like it, but I'll do it. And then we still have to worry about 2 pi to 4 pi. How am I going to get those? I'm just going to add 2 pi to each of my answers from part A. So when I do that, I get 13 pi over 6, 23 pi over 6, 17 pi over 6, and 19 pi over 6. And that's that for 34, I think. Questions? Okay. Who's next? Sid? 44? Sure. Just grab it there. So right away, this one looks just like a quadratic, right? And I'm just going to think about this in terms of y's for a moment, just to make the solving a little bit easier. So notice that the leading coefficient is 1, so I can't just do the factoring shortcut. I'd have to do the long factoring, or alternatively, I could use the quadratic formula. I'm just going to use the quadratic formula because we did a long factor example in the notes. We haven't used the quadratic formula yet this year, so I figure, yeah, might as well do that. So we'd say y equals negative b plus or minus square root b squared minus 4ac all over 2 times a. So we have negative 3 plus or minus the square root of 3 squared minus 4 times 2 times 1. All over 2 times 2. So that's negative 3 plus or minus square root of 1 over 4. The square root of 1 is 1, so I'm either going to get negative 4 over 4 or negative 1, or I'm going to get negative 2 over 4 or negative 1/2. So I say y equals negative 1 or y equals negative 1/2. Everybody okay there? I burnt through that quadratic formula, but you guys should be pretty good at doing that, right? You got a lot of practice last year. And then I'll substitute in my values for, my variable back in for y. So I have x is equal to the sine inverse of negative 1, and x is equal to the sine inverse of negative 1/2. So I'll go to my unit circle, and I'll look for the place where the y-coordinate is negative 1. That happens exactly one place at 3 pi over 2. And then I'll look for where the y-coordinate is negative 1/2. That happens at 2 places, 7 pi over 6 and 11 pi over 6. So that's my answer for part A. For part B, I know I'm going to have my answers for part A, as well as angles that are coterminal to these and negative. So I'll just subtract 2 pi from each of these. So that's going to give me negative pi over 2, negative 5 pi over 6, and then negative pi over 6. Oops, this is C, though. I don't know what I'm doing. That was C. B should have been the infinite ones, right? And they all need to be listed. Sorry about that. You guys, once you have A, B is pretty easy to write. And then D, well, we have our answers from A. We need to look at the negative answers from part B and see if any of them are greater than negative pi. They all are, right? So I need to list all of those. Should have just written C there instead of A and then wrote down the answers, but that's what I get for jumping the gun and writing down the answer for A to start with. And then the last part we need to worry about is the stuff between 2 pi and 4 pi. How do I find that? Add 2 pi to each of my answers from A. So that would be 7 pi over 2, 19 pi over 6, and 23 pi over 6. Cool with that said? You're welcome. And obviously you could have solved that by factoring also, right? We mentioned that right from the get-go, that one factors. But I figured it's worth doing the quadratic formula because does everything factor? No. At least not easily, right? Like technically, if you want to factor over the complex numbers, you can do that. Everything factors. But to do the factoring, you'd have to solve the polynomial anyway, at which point it's like... but yeah, not everything factors easily. In which case, you'd have to use the quadratic formula anyways, and then you're like, what's the difference? All right. Probably got time for a couple more. Are there any more that we want to talk about? We haven't done any where the coefficient on x is not 1. We should probably do at least one of those. Do any of those look appealing to you guys? 41? Okay. All right, so my first step is going to be to square root both sides. So I get plus or minus, and that turns into just the square root of 2 over 2 when I rationalize the denominator. Everybody okay with that? Okay. So I'm going to split this into 2 equations. So x over 2 is equal to the cosine inverse of positive root 2 over 2. And then x over 2 is going to equal the cosine inverse of negative root 2 over 2. And remember, when the coefficient on the x is no longer 1, I like to find the answer to the infinite solution first, and then use that to generate my answers for like A, B, and C, A, C, and D. So I'm going to go to my unit circle here and look for the places where cosine is equal to positive root 2 over 2. That happens at 2 places, pi over 4 and 7 pi over 4. And then also where it gives me negative, that happens at 3 pi over 4 and 5 pi over 4. Oops, we shouldn't write it this way though. Because we're doing the infinite one, I'm getting a 2 pi k as soon as I go to the unit circle. I should write it this way. Everybody okay there? Okay, and then when I solve for x, I have to multiply both sides of these equations by 2. there's my answer for B. Because I can get the x by itself. Yep. Good with that? Yep. That's fine. You can ask. I just answer matter-of-factly. All right. So for part A, we want the answers between 0 and 2 pi, right? So I'm going to look at each of these infinite answers and pick some values for k to see if I can get an answer in between 0 and 2 pi. So the first one, if we pick k to be 0, we get pi over 2. That's an answer, right? If I pick k to be 1, it's going to be too big. If I pick k to be negative 1, it'd be too small. So that's the only answer I'm going to get from the first one. Everybody okay with that? Because if k is 1, I'd have 4.5 pi, way too big. If k is negative 1, it's negative 3.5k, definitely too small. Cool? Okay. If I go to the next one, if I pick k to be 0, too big still. Everybody agree with that? 7 over 2 pi, way too big. That's 3.5 pi. If I pick k to be negative 1, I'm going to get negative pi over 2. Too small. That one gives me no answers. All right? I'll go to the next one. If k is 0, I get 3 pi over 2. That one works. If I pick k to be negative 1, I get a negative answer and it's too small. If I pick k to be positive 1, I get something way too big. So that's the only answer I'm getting from the third solution. And I'll go to the last one. If I pick k to be 0, too big. If I pick k to be negative 1, too small. So these are my only two answers for part A. For part C, I definitely have my answers from part A. And then we have to check to see if I can get a negative, something in the range from negative 2 pi to 0. If I recall, that only happens here and here, right? When k is negative 1. In that first one I underlined, I get negative pi over 2. And in the second one, I get negative 3 pi over 2. So that's my answers for part C. Everybody okay there? No. That's just a happy accident on this problem. And then D is the interval there. So I have my answers from A. I have one answer from C that I should also include, or one of the negative answers from C that I should also include. And then I have to go back and check to see if any of these guys fit when, so I know that like when this guy and this guy, when k is 0, I get a solution from those, right? So that's it. Everybody okay there? Slipping? Well, here's what I usually do. I usually start with 0. And if I get an answer, I have to check, okay, were there any before that or any after that? And if there's not, then I know I'm done. If 0 doesn't work, if it's too big, then I should check a negative one to see if there's a smaller one. But if that doesn't work either, I'm done, right? So I'm just kind of like, oh, did that work? Yes. Then I have to check above and, before it and after it. If it didn't work, I just need to check whichever way I need to go. Like if it was too big, I need to check something smaller. If it was too small, I need to check something bigger. But usually I just start with k equals 0. Does that make sense? And if it helps, like, you can start by just writing all the values for each one of these for k equals -1, 0, 1, just to kind of see. And if you use the -1, you probably need to check before it, for that particular solution or whatever. Okay? Of course. And sometimes, again, when you're doing this for the first time, it's helpful to write down, like to write out all the values that, or several values, like for, just -3 to +3 k's. Just write them all down, and you can just like, oh, I need this one and this one from there. I need that one and that one, or just this one, and you just can kind of pick them out. It's kind of easy that way, at least until you get a feel for like how to do it without writing them all down. But it's not a bad exercise to do that. But you see why I did part B first here, right? Is that I know how to get where to check for any other answers. If I have part B, I can do the rest of them really easily. Or at least, maybe not really easily, but easier. Are there any more that we want to do from this set? Any more questions to talk about? $33, you said? Okay. All right. So the first thing I'm going to do is get that sine squared by itself, so I'll divide both sides by 10. And then we'll square root both sides. And I notice right away that when I square root 1/2, I have to rationalize the denominator, yada, 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 and that's where the square root 2/2 comes from. I'll break this into two equations, so I'd have x equals sine inverse of the negative square root 2/2, and x equals sine inverse of the positive square root 2/2. I'll go to my unit circle and look at the y coordinates. So the places where the y coordinate is negative root 2/2 is at 5π/4 and 7π/4. And the place where it's positive is at π/4 and 3π/4. That's my answer for A. For B, I noticed that this guy and this guy are pi units apart. And, nope, sorry, not those two. Those two. And then this guy and this guy are also pi units apart. So I can condense my infinite solutions from 4 to 2. So if I take the yellow ones, I can write that as π/4 plus pi k instead of 2 pi k. And I can take, for the blues, 3π/4 plus pi k, where k is just some integer. Okay with that? Okay. So we have like π/4 and 5π/4. And the distance between those two solutions is pi units either way. So instead of going like 2 pi to get here, and then doing, like 2 pi to get there, I can just do pi and get, I can do pi to get there and then 2 pi back, or another pi back, you know what I mean, Miguel? So if I just, it allows me to condense down. That only works when you have two things that are like pi units apart. They have to be pi units apart, or that doesn't, you can't condense them together. You just get two answers with 2 pi's. Yeah. But that just allows me to shorten things up a little bit. All right. For part C, I need things between negative 2 pi and positive 2 pi. So I definitely have all my answers from A. That's the stuff between 0 and 2 pi. And then I'm going to need the stuff then between negative 2 pi and 0. So to find those, I'm just going to subtract 2 pi from each of my answers in A. So it's going to be negative 3 pi over 4, negative pi over 4, negative 7 pi over 4, and then negative 5 pi over 4. Yeah, Michael? No, the convention is usually start with the smaller one, but it doesn't really matter. It's still the same solution set. Good question, though. And on D, we have between negative pi and 4 pi. You get all my answers from A. And then from C, I'm going to go back and look at the negative answers and pick the ones that are bigger than negative pi. So that's those two, right? The other two are too small. They're less than negative pi. You good with that, James? Okay. So that was the stuff between, and then this is the stuff here. Oops. And then I'm going to need the stuff there. To find those answers, I'm just going to take my answers from A and add 2 pi to them. So that's going to give me 13 pi over 4, 15 pi over 4, 9 pi over 4, and then 11 pi over 4. And that'll be it for D. Cool with that? Okay. So we have a little bit more solving to talk about. I know, it's exciting. So this is the last set of examples from section 5.2. Let's say we want to solve tan 2x times sine squared half x equals tan 2x on the interval from 0 to 2 pi. What's the first thing I'd want to do to try to, solve this equation? What do you guys think? Divide by what? Divide by tan of 2x. What happens if that's equal to 0, though? Could it be equal to 0? Tangent can definitely have the value of 0, right? So I definitely don't want to divide that because potentially I'm dividing by 0 when I do that. Subtract it. Somebody mumbled that. I'll take that idea. So let's subtract and move everything onto one side. I like that idea. Then what? It's similar to Megan's idea of dividing. Factor. What can I factor? I can take a greatest common factor of tan 2x. So Meg, you weren't too far off there with the idea to divide. Everybody's okay there. See what we did? And I used the bracket there just because we already have a bunch of parentheses. It just seems like it's a little cleaner to do it that way. You don't need the bracket. You could write a parenthesis or whatever. Then what do we do? What if we do this? I can do that, right? Now that it's in a factored form, I can set each factor equal to 0. Notice that what that's allowed me to do is separate off the tangents and the sines into two separate equations that I can deal with them separately. Which is nuts, right? Because there was not a way for me to deal with the two of them in the same equation together. That was going to be a problem. Everybody okay so far? Okay. So for this one, I'm going to be taking 2x is equal to the tan inverse of 0. And then over here, I'd have sine of 1/2 x equals, I added the 1 over and square rooted, so I'm going to end up with plus or minus 1. So here I'd have 1/2 x equals the sine inverse of -1, and 1/2 x equals the sine inverse of +1. So far, so good? Sam? Sure. Okay. So I'm going to go to my unit circle now. I'm going to look for all the places where tangent has the value of 0. Tangent is 0 when the y-coordinate is 0, because tangent is y over x. So this happens at two places, pi over 2, and at 3 pi over 2. Oh, I'm sorry, you're right. That's wrong. 0 and pi. Thank you. Similarly, I'm going to do the same thing over here. So the place where the y-coordinate is -1, well, there's just one place. And where it's +1, again, there's just one place. And then to solve for x, on the first two equations, I'm going to divide both sides by 2. That's going to give me x is equal to pi k. And then x is equal to pi over 2 plus pi k. On the second two equations, I'm going to multiply both sides by 2. It's going to give me x is equal to 3 pi plus 4 pi k. And then x is equal to pi plus 4 pi k. Everybody good with how I've got these 4 answers so far? That's not my final answer, but that's what I'm going to use to get my final answer. Remember, why am I finding the infinite solution first? Because I had coefficients on my x's, right? That's when I do that. Okay. So, let's look at the first solution. When k equals 0, what do I get? 0. Is that an answer? Yeah, right? 0 is in the range from 0 to 2 pi. When k equals 1, what do I get? Pi. Is that in the range? Yep. When k equals 2, I get 2 pi. Is that in the range? No. Because I have the parenthesis at the end rather than the bracket. Be careful about that. And obviously, if k is -1, I get a negative, and that's too small, right? Okay. So those two answers came from the first part. Now look at this one. I'll do the same thing. When k is -1, obviously I'm getting a negative, and that's too small. When k equals 0, I get pi over 2. And that's good. When k equals 1, I get 3 pi over 2. That one works. When k equals 2, I get something too big. So that's my answers from the green. Now let's go to the blue. When k equals 0, what do I get? 3 pi. That's too big. Okay, well, let's check a negative. When k is -1, what do I get? Negative pi. That's too small. So the blue one contributes no answers. No help. Now let's look at the pink one here. When k equals 0, I get pi. Already on my list. I don't need to list it again. I'll do this, I guess, to let you know that that also came from the pink solution. Okay, when k equals 1, what do I get? 5 pi. That's too big. Okay, when it equals -1, I get -3 pi. That's too small. So these are my 4 answers. Really, just the yellow and green equations were the only ones that really contributed anything, which is fine. Not every time you're going to use all the general solutions you get. It'll depend on that interval. Okay with that idea? Okay. Let's do another, right? That's about as, they're all kind of the same from there on out. Let's do this one. Okay, so let's say we have sine squared x is equal to sine x, where the x's are on the interval from -4 pi to 2 pi. What do you want to do first to solve this one? Can I divide both sides by sine x? No. What should I do? Yeah, get it all on one side, so we'll subtract the sine x over. Then what can I do? Factor a sine x off. Pretty good with that. Then I can set each piece equal to 0. So I need the places where sine inverse of x is 0, and the places where sine inverse of 1. Okay, so I'll go to my unit circle. This happens at 0 and pi. This happens at pi over 2. But remember, this is not going to be my answer. Why not? That's the interval I'm solving over. Well, these guys are definitely all in that solution set. Is there anything coterminal to 0 that should be in that solution set? Yes. What else should be in there? 2 pi, -2 pi, and -4 pi. So all of those 4 answers came from 0. Everybody agree with that? They're all coterminal. Okay. Let's look at the pi now. what answers coterminal to pi would be on this list? Okay, so if I subtract 2 pi, I get negative pi. That should be on the list. And what else? Negative 3 pi. If I subtract 2 pi again, that should be on the list. If I subtract 2 pi again, though, too small. If I added 2 pi, I get too big. So these are, all those answers are coterminal. So now let's look at this guy. Okay, what answers would I get here from him? If I add 2 pi, I get too big, right? If I subtract 2 pi, I get 3 pi over 2. That should be there. If I subtract 2 pi again, I get negative, not 5 pi, 7 pi over 2. That should be there. But if I subtract 2 pi again, I am too small. So those are my answers. Everybody okay with how we did that? So again, once we found our unit circle answers, we can just find the things coterminal to them, and we're done. Why didn't I have to worry about finding the infinite solution first and worry about using k's instead of just adding and subtracting 2 pi's all willy-nilly? Good. The coefficient on the x is 1. Very good. What do you guys think? You're good? You're adequately impressed by what we've done here? Okay. Well,